So all that we're doing when we see these little sub 1, sub 2, sub 3, sub 4, it's just telling us which complex number we're talking about. So I think you guys are good with this, but if you look below, remember it's real, imaginary, and for example, -1, you're going -1 units to the left on the real axis, and then you're going down 1 unit, and then you just do your dot right about there, which you'll see again below. So the hardest part about doing number two, or first rewriting the first complex. So the hardest part of number 2, again, as I said, sorry, I'm re-going over part of it, is to find R, which is the hypotenuse of the right triangle we create. So we're going to use Pythagorean theorem, right? It doesn't matter if we call this side A or the side B or vice versa, but we're using Pythagorean theorem to find the hypotenuse. The value should be positive. The hardest part is to find theta. At what angle is our dot represented for the terminal side? So if we plot, for example, number 1, if we do the dot z sub 1, we would go to the left 1 unit, up 1 unit, and I would do my dot right about there. I would rewrite this as -1, comma 1. You know that's x, y, you know that's cos, sine. You know that tangent is sine over cos, so we'd say the tangent is equal to 1 over -1. So then to find theta, we're using inverse tan. So you're saying at what angle in quadrant 2, you got to be careful with quadrants, is the ratio for tan -1. Now I would always look at just the first quadrant, and I know that at 45 degrees tan is going to be 1. I know that at 30 degrees tan is going to be √3 over 3. Right, you get it from sine over cosine. And at 60 degrees the tangent is going to be √3. So then I decide, okay, which of these values has some type of 1. You don't need to worry about the positive or negative. You just look in first quadrant. Okay, 45 degrees deals with some kind of 1. So then what I'm going to do is I am going to look at reflecting that dot over here to the same spot for -1, 1, but in quadrant 2. So obviously this terminal side has to be between 90 degrees and 270 degrees. What am I saying? It has to be between 90 and 180, right? So if I take 45 and I reflect it across 45, or add another 45, sorry, 90 degrees plus 45 degrees would get me 135 degrees. Since theta has to be positive, we know that that dot, that terminal side, is located at 135 degrees. It's a reflection of 45, where the tangent ratio is 1, into quadrant 2. And because we know that in quadrant 2, our cosine is negative, or x is negative, and our sine is positive. So because we have a positive over a negative, our tan ratio right here would be -1. So it makes sense that we're reflecting that 45-degree angle into quadrant 2. We're going to add 45 to 90, and that's how we end up with 135. So now that we have r and theta, that's all we need to go to trig form. R, using Pythagorean theorem, was square root of 2, and theta was 135 degrees, which is also equal to 3 pi over 4. You can write your answer in radians or degrees. So I would say z sub 1 This complex number in trig form is r, or square root of 2, times the cosine of theta, which is, I'm going to use 135 degrees, and plus I sine of that same angle, 135 degrees. So that is our value written in trig form. In the spot of 135 degrees, you could write that as 3 pi over 4. Either is the same value.